All right, so here we are with the next section, 10.3 areas of circles and sectors. So we've talked about circles quite a bit lately in our previous unit. Now we're going to look at area. So recall that the formula for the circumference of a circle C with a radius r is given by the formula that we can either say circumference is equal to 2 times pi times radius, or in my preference, circumference is equal to pi times diameter, pi d. Below a circle with a radius r and circumference c is being divided into congruent pieces and then rearranged to form a figure resembling a parallelogram. So we can see here the entire circumference of the circle cut up into a number of different little slices of the pie here, little pie slices, and then just kind of alternated back, forth, and pieced together. You notice what ends up happening here is it looks a lot like a parallelogram. It's not a perfect parallelogram because each one of these is technically curved a little bit because each one of them is a little slice of the outside of the circle. But as we get more and more slices, this becomes more and more straight and actually becomes more upright as well. So not only will it look like a parallelogram, but it will actually look more like a rectangle. So as the number of congruent pieces increases, the rearranged figure looks more closely approaching a parallelogram. The base of the parallelogram is 1/2 of the circumference, right? Because you'll notice since it alternates, half the circumference is here, half is here. So 1/2 C and 1/2 of the circumference there. But the height over here, now it's not a height quite yet because it's kind of a little bit diagonal here, but that's r. But as you get more and more slices here, the whole thing kind of straightens up and it actually does become the height of what essentially is a rectangle. So the rectangle here is kind of like half the circumference times the radius then, which would be the base times height. So the area is half the circumference times the radius. Because the circumference, remember, is 2 times pi times radius, the area of the parallelogram then would be half of the circumference. So half of 2 pi r, and then times the height, r. Right? So half of this, remember this right here, when we say c, that's really 2 pi r, because that's circumference, 2 times pi times radius. So the base of the triangle here, or the base of the triangle, the base of the rectangle is 1/2 times 2 pi r, and then the height of the rectangle is r. By the way, I guess I forgot to put in height over here. So when we simplify that now, let's take 1/2 times 2 times pi times r. The 1/2 and the 2 cancel out. So what are you left with? Pi r squared, which of course is the area formula for a circle. So the area formula for a circle essentially comes from cutting up a circle into just many different little slices here. And the more slices that you can have, the better, because then when you piece them together, it eventually resembles a rectangle. And the limit sort of becomes a rectangle. And so the 2 pi r times 1/2 times r is the base times height of your rectangle. So that's just a little bit of a long explanation of where pi r squared comes from. And just like our area formulas from the previous section, really we're piecing it together into rectangles. So it all comes back to these rectangle formulas, or the parallelogram formulas, base times height, and even the circle can be pieced into a rectangular shape. So now that we have that, let's just do some pretty simple, straightforward area problems here with the circle. So what is the area of the circular putting green shown to the nearest square foot? I'm a big fan of golf. Just finished watching Brooks Koepka win the 2019 PGA Championship for his 4th major. So love talking about golf this time of the year. So, all right, so area is equal pi times let the radius squared. So notice the diameter over here is 20, so that means the radius is 10. So pi times 10 squared. So that's pi times 100. And 100 pi is approximately 314. And we're looking at square feet then for our units because it is an area. All right, so then use the area of a circle to find the missing measures. So kind of working your way backwards here. Find the radius of the circle with the area of 95 square centimeters. So remember, area is pi times r squared. We're saying the area is 95 square centimeters. So area is pi r squared. So a little bit of algebra here. We're going to get, for all my railroad tracks, cancel out pi from both sides here. And so I'm just going to keep it as 95 divided by pi over here then is equal to r squared. And if you have a calculator, you can do that. But then, of course, to get r by itself, we're going to take the square root of both sides. And so the square root, r will be equal to the square root of 95 over pi, which is approximately 5.5 centimeters.